Part 2 of the June 2012 M2 Ed Excel paper. This is question 5, a question I well remember, caused a certain amount of heartache at the time because students and teachers are so used to questions being of a particular type that sometimes get put off when they change it. Because most of the impulse and momentum questions we've seen have involved I and J. Now I'm tempted to do a kind of nice clever vector triangle with momentum and impulse, but I'm worried I might switch everyone off if I do that, and you might say, well, that didn't help very much. So I'm going to do a slightly longer way, but I think most students, from my experience, would find it a little bit more helpful. Because we're so used to the I and J structure, why don't we call this 30 because of that, the direction 30i. You can use column vectors as well if you want. And then all we have to do is convert this 12.5 vector into I and J form. But we do know the angle alpha here, so this is 90 plus alpha there. So this angle is alpha that I've marked here, and this is 12.5. So we can split into two components. There's a component here, the vertical component, which is 12.5 cos alpha, and there's a horizontal component which is 12.5 sine alpha. But we do know what cos and sine alpha are, hopefully, without using a calculator. It's a 3, 4, 5 triangle. So cos alpha is 4 over 5, so that's equal to 12.5 times 4 over 5, so that equals 10. And this one here is 12.5 sine alpha. Sine alpha is 3 over 5. So that's 3 times 2.5, which is 7.5. Okay, so I'm now able to write this in my I and J form that I probably crave, because then it becomes a question which is more like something we've seen before. So let's just do that. So and be careful here, the I component is minus 7.5i, because it's going in this direction, plus 10j. So we can now just use our momentum equation. Impulse is equal to mv minus mu. So we have minus 7.5i plus 10j equals to 0.75. The final velocity, and remember the initial velocity is 30i, minus 30i. Right, now if I times that by, if I divide by 0.75 there, I get, my apologies, the mass is 0.25. I'm sure you recognise I was wrong. I can hear my students shout at me almost when I do these things. Right, so then that's times by 4. So that's minus 30i plus 40j equals to v minus 30i. So that gives us v equals 40j. And that's it. So what looked hard, now it's actually going upwards. So find the direction of motion. Looks familiar here. There's no angle again, it's going upwards. So the answer to part A is 40 meters per second. And the second part is vertically upwards. Okay, so that's not as bad as it first appeared, is it? But it was just the lack of structure at the beginning. It can be done, you'll see the mark scheme with a vector triangle in it and various things, but which might be slightly quicker, but I think this That's fine. Okay, let's move on to the next question, question 6. Okay, so this is a power question again. A car pulling a trailer up a straight road with a given angle, and we're given the power, we're also given the velocity, and we're given all the resistances, and we need to work out the acceleration and then the tension. So it looks pretty standard for the most part, this, which is just as well, because not all of it has been so far. So okay, let's just draw my little trailer pulled by a car. The car has mass 1,200, so therefore weight 1,200 g, inclined at an angle alpha. The trailer has mass 400, therefore weight 400 g, inclined at the angle alpha. As I said, we're getting the resistances. On the 1,000 newtons on the car, and also 200 newtons on the trailer, there's going to be a tension pulling the trailer forward and a tension, an equal and opposite tension pulling the car backwards. And of course there's a driving force. Okay, so that's my diagram. Always like to see a diagram. Now we can, as almost always is the case, it's a case of using P equals FV, and here we've got 60,000 is equal to force times velocity, which is equal to 10. So that gives us F equals 6,000 newtons. Okay, so now we can apply F equals ma, and I think that will get us the acceleration directly. I'm going to do the whole system, and then I'll apply it probably to the trailer for part B. Okay, so F equals ma for the whole system. That eliminates the t basically, so we've got we're looking at the whole thing together. T cancels out, so we have F driving forward, which is 6,000. Away the two weights, which are the components of the two weights. Remember, it's the horizontal component, well, not the parallel component down the slope that we need to consider. I'll just draw that in just in case don't know what, hopefully you know what I'm talking about. That's 1,200 g sine alpha because it's away from the marked angle here, and that's 400 g sine alpha because it's away from the marked angle there. Okay, let's not forget the two resistances. I would advise writing them down individually rather than combining them, because the way these things are marked is you mark for the correct number of terms in your first equation, so it is prudent to write down the forces like that rather than do some, we can all see that's minus 1,200, but I wouldn't write that. Your first line should be, your first line is normally 2 marks for that line, so we really want to make sure that we've got the whole thing correct. So it's better to keep with the correct number of forces, and that's equal to 1,600A because the total mass is 1,600A. I'm going to do a bit of cancelling. You'll forgive me, I'm just going to try and do this without a calculator. Everyone else is reaching out for their calculators, but just please let me do my own thing on this whilst you go and get your calculators. So zeros cancel from all of these. Okay, and then we can sub in our values of 9.8. So that's 60 minus 12 times 9.8. Now sine alpha is 1 out of 14, I think. Unless I'm thinking about, yeah, it's 1 out of 14. Minus 4 times 9.8, 1 out of 14. Now I can combine these two, which is minus 12 is equal to 16a. Right, okay, so that gives me, maybe this isn't such a clever idea, 48 minus 12, let's combine these two, that's minus 16, 9.8 times 1 over 14 is equal to 16a. I'm going to divide through by 16 now, so we've got a is equal to 3 minus 9.8 over 14. Right, so, okay, I'm going to use a calculator now. Oh no, don't give up, John, you can do it. 3 minus 4.9, sorry about this, you can always fast forward if you want, divided by 7, so that's 2.3. Okay, I'm sure. I think if I was doing it in the exam I might use a calculator, but I still would do the little bit of cancelling before, just to try and so that I'm putting less into the calculator. And actually, the less you actually have to put into the calculator, the more likely you are to be accurate. Anyway, I'll stop chatting on about that. Now we need to work out the tension. Now I need to look at either of the trailers in separately, or either of these particles separately. I'm going to do the trailer, it's just simply because there's fewer forces involved. So I'm going to pick on look for the trailer. So I'm going to do F equals ma on the trailer. So F equals ma on trailer. We then have the T that's pulling it forward minus the 400 G sine alpha minus 200 is equal to 400 times by the 2.3. Okay, so when I work all that out, I will get okay, so then taking that over, I get 200, 400 times 400G, so that's 400 times 9.8 times 1 over 14 plus 200 plus 400 times 2.3. Okay, I think I've done my non-calculator things long enough. The answer is 1,400 newtons when you work all that out. Okay, so that's the power part of the question done. It then talks about the tow bar braking when it's at 12 meters per second, and we're using, it's a pretty standard work energy question now. So we've got something that starts off at 12 meters per second at here, and then it comes to rest at some distance up the slope. Okay, the velocity here obviously is 12 meters per second. The velocity here is 0, and we've got the height that this has gone above, because this is alpha here, is d sine alpha, so that's d over 14 is the height above, and we need that when we're going to work out our gravitational potential energy. So let's get on with it. We have the, as I say, I tend to use this structure, which I do think is helpful because it will, everything can fit into this one thing. The work done in this case is work done by friction, work done by resistances, not with friction, work done by external forces. It can be friction in other questions, but here it's just talked about the trailer. So we're looking at the trailer, so that here we're going to have it's going to involve the 200 Newton force. So my delta KE it's going to be a decrease in kinetic energy, isn't it? Because it's gone up the slope. So that's minus half times by m, and the mass of the trailer, if we're looking back, is 400, times by 12 squared, plus the increase in potential energy, which is m, which is 400, times 9.8 times 1 over 14 d, or from there. And that's going to be equal to the work done by the resistance force. Now, the resistance force is going to take energy away from, mechanical energy away from the system. So that will be minus, and I forgot what that force is again, 200d. So we basically have an equation we need to solve. Okay, let's work out our individual terms. Okay, so the first is minus 28800. The 400 times the 9.8 divided by the 14 is 280d, is equal to minus 200d. If I rearrange all that, as 480d is equal to 28800. That gives me a distance of 60 meters. Okay, so that's our work energy equation done. Fairly standard, really. Not at this stage in the paper. We're not going to complain too much about that. Let's look what the last question has in store. Projectiles. It's normally a nice way to finish. Right, okay, we've got quite a bit of information here. The highest height is 10, is key obviously for the first part of the question. We don't know what the velocity is, so we don't know what the initial, let's call it uy and ux, the horizontal and vertical components of the initial velocity. So that will get us part A quickly enough, because we can just apply v equals v squared equals u squared plus 2as vertically, because we know the final velocity is 0. The initial velocity is the uy we're trying to find, and then that's plus 2 times minus 9.8 times by the 10. So that gives us uy squared is equal to 196. So that gives us uy equals 14 as required. Okay, now, so that's the vertical component sorted. Let's look for the horizontal component. There's quite a lot to consider here, which is why it's 9 marks. So we're basically going to have to bring in these two bits of information here to work out the horizontals component of the initial velocity. I can work out the time taken to get there using the height 52.5 or minus 52.5 with the vertical component I now know, because I know that is 14, and the fact that it's dropped 52.5 in a certain amount of time. So we can work out the time taken. If we can work out the time taken, then we can use the horizontal component, which must be constant, to work out what the speed would be, the horizontal component of the speed would be. So that's what I'm going to do. I'm going to apply, look at what we know. If I apply S equals ut plus half at squared, so that gives me minus, don't forget the minus because it's below, 52.5 is equal to u, which is 14t, minus 4.9 t squared. So that breaks down to 4.9 t squared minus 14t minus 52.5 equals 0. Again, I'm going to try and see if I can factorise this rather than just plough into it with a calculator. Divided by 0.7, I get 7t squared there. I get 20t there. And dividing that by 0.7 would be 70. Yeah, minus 75, I knew it was. I checked with the calculator anyway. That factorises, which is 7t and t, and then we've got I think 5 and 15 minus 5, which would give me my minus 35 plus 15. Obviously the negative one is not appropriate. That basically arises from this point here, which isn't relevant. The time before it would have touched. So we've got t equals 5. Now we have t equals 5. We have the horizontal. We can work out the horizontal velocity constant, and it's gone 50 meters. Okay, let's just stop fiddling around with this. Okay, all right, let's get. So the horizontal velocity is constant. So it's gone 50 meters in 5 seconds. So we've got ux, the horizontal, times by 5 equals 50. So ux equals 10. Now there are 9 marks, so they want us to do it wants the final speed of projection, and of course we've got the 14 going upwards and the 10 across. So the speed, we'll call it u, is equal to square root of 10 squared plus 14 squared, and that equals to 17.2 or 17 to 3 significant figures. Okay, or 17 to 2. Okay, so that was, I don't think that was particularly difficult. 9 marks at this stage in the paper. Okay, right, 5 marks for the last bit. It says find the time after the projection when it's moving parallel to OB. Let's just take this out a bit more now. You don't need to see the, let's just tie this up a bit. Okay, that's better. So it's basically asking for the time when it's parallel to this direction. If I could draw a line between O and B, that would help. The time when it's going at this direction here. Well, we can work this angle out easily. That's tan alpha is equal to 52.5 over 50, which is 1.05. And then we can just use the fact that we know that the horizontal component is 10. Now let's make sure that I mark on the correct component here, correct angle. This angle is alpha here, I believe. Or is it? Yeah. Nope. Wrong angle. This angle is alpha here. We can see that. Hopefully we're playing with the angles, Z angles or whatever. That's the angle alpha. It's because it's with the horizontal. We've got horizontal here. So that's the angle alpha because those two are parallel. So that that must mean that this side is 10 tan alpha, which is 10 times 1.05, which is 10.5. So we have that means that the vertical component is minus 10.5. That's clear because it's downwards. So now we pretty well need, because it wants the time it takes for it to get to be parallel. So we pretty well got what we need, because we know what the initial vertical speed is 14. We know what the final speed is, it's the minus 10.5. So we can apply v equals u plus at with these values. We'll get minus 10.5 is equal to 14 minus 9.8 t, call it capital T. So that gives me 9.8 t is 14 plus 10.5, so that's 24.5. And so dividing that by 9.8, it comes to exactly 2.5. Well, not exactly, but using our answer for G, it does 9.5 seconds. Okay, this wasn't too bad, a little bit of work, but I think some of the earlier questions were worse than those final two questions, which hopefully the message is, if you get stuck in the middle, doesn't mean that at the end it's going to be much worse, really. I think it's quite long, but relatively standard. Okay, June 2012 done.